And welcome back to Good Morning Kenya. My name is Mike Megwe. We are glad that you're still watching KBC Channel 1. Now, let's talk about the engineering sector. Now, when you look at the country, the investment, there's huge investments, billions of shillings in matters of housing, roads, energy, transport infrastructure. And also, at the same time, matters of rapid urbanization, climate change, tech disruption are forcing countries, not only Kenya, to rethink how they build. Now the question is, are we designing infrastructure that will serve us 30 to 50 years from now? How can we scale green growth, smart infrastructure, and a resilient future? That is the conversation we are about to have with one engineer, Gabriel Jabongo, who is the President, Association of Consulting Engineers of Kenya. Welcome to Good Morning Kenya.
Thank you.
And also Engineer Nathan Yego, who is a member of the Association of Consulting Engineers of Kenya and also the ASEC Conference Committee. Karibu sana.
Thank you so much.
How are you doing this morning?
I'm doing fine, thank you.
Yes. I'll start with you, Mr. President. The engineering sector, since you're the President of the Association of Consulting Engineers of Kenya, how is the engineering landscape looking today in the country?
The engineering landscape is looking good. Mm-hmm. The engineers are really trying what they can do.
Yes.
They are doing their best. However, there's been some challenges here and there in the engineering landscape.
Yes.
And these challenges has been brought about by the procurement process. We sometimes try to not align well with the engineering functions. We find that the procurement, the way it is being done, at the beginning the engineers are there, but somewhere in the middle you find that the procurement team take it over, and whatever the engineers have already thought of and worked up along with, sometimes it's misaligned when the procurement section takes place. Yeah.
But that is going to be addressed?
Yeah, that one we are discussing. It is being discussed, and we hope that the policymakers will look at some of these matters and bring them, deal with them.
Yes, yes, very important. Engineer Nathan,
yes,
you're also part of the Association of Consulting Engineers of Kenya. You know, you're getting into, and you represent a generation that is now entering or has entered the engineering profession at a time when now there is rapid transformation when you're talking matters of technology, environmental change. How different from where you stand is the profession as opposed to when previous or what previous generation of engineers prepared for?
Right, thank you for your question. Yes, there is, we need to be alive to matters of technological changes.
Yes.
So we've moved from, previously you had the industrial, you had the agrarian revolution.
Yeah.
Now you're at the precipice of industry 4.0 and also 5.0. I remember when I joined campus, engineering drawings were probably, you needed to move around with a T-square.
Yeah.
To do your engineering drawings.
You can tell this is an engineering student.
Yes, then we moved to now the various CAD softwares.
Yes.
Now, with the CAD softwares, that was basically 2D. Now we have moved on from CAD to building information modeling, whereby with one software you can be able to design and even do the life cycle cost.
Yeah.
So we have technological changes that have made engineering much faster. We're able to execute projects in a faster way. We're able to even do life cycle components,
yes,
all in one-stop shop. I remember hearing stories of how my seniors would they'd go to the office with a white shirt, and then they'd come out with the shirt with a lot of graphite.
Yes.
Because they'd have to be drawing the pencil, rubbing, and so on and so forth. And even the cross-collaboration across the various engineering disciplines. Like for instance, with advanced technologies, you can be able to resolve conflicts faster. Before they'd had to draw with a tracing paper, and then they'd come and overlay on each other, just so that to see if there's any conflict. But now that can be done even when you're in different continents.
Thanks to technology.
Exactly, thanks to technology.
And Engineer Gabriel, you know, this also speaks to engineering transformation, and it suggests that traditional engineering is no longer enough. From where you sit, what has fundamentally changed about now how the infrastructure going forward should be planned?
Things have changed the way you have mentioned. The infrastructure which is being done right now should be resilient. It should be the test of time. It should be smart. It means that most of the infrastructure is supposed to have sensors. They are supposed to be monitored so that if there is anything which is going to be a problem, then it can be sensed earlier. It can be addressed earlier before the actual problem comes in. And this happens almost in all the infrastructure area, starting from the energy, the water, the roads. All these should be resilient. They should be smart. And they should be able to test the test of time. Although we are talking about 50 years, I heard you mention about 50 years. 50 years is quite a huge time span. We talk about 20 to 25 years in some of these projects. 50 years, I'm sure even you will not be there to know. But we can say that we're designing for the 50 years. But within 20 or so years, some of us will have existed. So the new generation which will come up will also say now they want to do for 100 years. So
because we have to think about the future.
We have to think about the future.
And actually, when we talk about that, the aspect of green growth, it has become quite popular. It drives conversation. But there are those who argue that it's often aspirational. It remains aspirational rather than practical. From an engineering standpoint, what does green growth actually look like?
The green growth itself is being advocated all over. All the countries want to go green, and therefore it means that you have to do what makes the green work. So if you're doing a building, that building should have some green part of it. It means that the energy system which is inside that building should probably be renewable energy. It should be monitored properly. It must be used efficiently. If it is water which is being used in that particular building, it must be efficiently used. Whatever is being done, we don't want something which is going to degrade the environment, but it has to be something which is complementing the environment so that our future generation who are coming will say that our forefathers did a good job. They left for us something. Otherwise, if we don't do that, then we end up destroying the environment, which is not good. So the green part of it is very, very important.
Because it relates to matters of climate change. There's something you said about Industry 4.0 and Industry 5.0. Maybe you can explain that to the viewer.
Okay. So when it comes to even probably highlighting our history, so there's a time in history where agriculture was the main driver of industry revolution. That was the agrarian revolution. We had the advent of the steam engine and the internal combustion engine. So now we are at a point where data and AI and industry, Internet of Things are what is going to drive the next revolution. And you find that where we are at right now, before we make any decision, you need to have the data. And the one who has the data determines the policy direction.
It's influencing the decisions.
That is influencing policy directions. And even ahead of probably the national conversation that's going to happen next week, before our conference and even during the conference, Vision 2030 has achieved quite a number of things. For instance, part of the pillars of the Vision 2030 was introducing of SEZs, the special economic zones. They have been introduced. Now, how do we move forward? how do we incorporate AI? How do we incorporate data analytics? How do you incorporate that data so as to be able to move Kenya from now a middle income to now an upper middle income? And this is where the convergence of the engineers are, because you find with engineers we have a wide variety. We have the young and the old,
of course.
and even within the engineering disciplines, we have the mechanical engineers, electrical engineers, civil engineers, chemical engineers, agricultural engineers. Because even when we think of agriculture, there's a lot of data that the agricultural engineers come and use so that you can be able to have flourishing agriculture. You have manufacturing engineers, industrial engineers, all at a convergent point so that you can be able to take advantage of the threshold where we are at. Because you have a lot of data, now it is us as the engineers to help the country move forward by embracing these principles.
And it's good you've mentioned artificial intelligence and data analytics. Which of these technologies, from where you stand, do you believe they are going to have the greatest impact on infrastructure within the country?
I'd say we can have both. We can have all. Because these are tools that are there to help us make better decisions, implement projects faster. A good example is, say, when it comes to 3D printing of homes. You find that it has basically reduced the cost of, not only cost, but also the time element of producing, or like CNC machining. The time it takes to produce a component has greatly reduced if you compare with conventional manufacturing. And so data analytics, combining it with artificial intelligence, combining it with Internet of Things, all work in a harmonious way so that you can be able to deliver results faster. Remember when you want a project, the things you look at, you want good quality and you want good time. And usually at times, if you want it delivered faster, at times people compromise on quality. Or if you want good quality, you compromise on time. But now with data analytics, AI, Internet of Things, there's no need to compromise.
The two can coexist.
They can all coexist, and we can be able to deliver projects much faster with good quality and in good time.
And Engineer Jabongo, when you look at our education system, especially in the universities today, are universities producing graduates needed for this shift we are talking about within the engineering sector?
Thank you very much. Our universities are doing their best to bring up the students, to channel the engineers in the field within the available infrastructure. You find that some universities, the new universities which are coming up, they have really improved on the equipment which is being used in the universities. The university which has been there for some time, they tend to still cling on to the equipment which were there, the notes which were there, and what is changing mainly is the technology. But the technology inside the university, some of them don't change. So you find that in all university, they have some old equipment which need to be changed. At the same time, you find that the cost of changing this, offering engineering courses is very high. So what sometimes it is done is that it's recommended that a university which does not have enough resources, they can collaborate with a nearby institution, not necessarily university. If you get a university nearby, the better, but a nearby institution which has got a better, well-equipped facilities for training of the university student. The university, when they come out of the university, they have a lot of theoretical information, knowledge, but they still need the practical knowledge. So when they come out, they look for mentors. And the mentors is where now the Association of Consulting Engineers come in. We take some of the students from the university who have just graduated, they are mentored, and they are shown this is the way. And then if you have mentored them for some time, maybe 3 years, and they are good enough, they can now start preparing their projects so that become full engineers. But it takes a bit of time, it takes a bit of training, a lot of training and mentoring. But the university, they are doing their best within the available space. Yeah.
Very important, especially the aspect of mentoring young engineers. Let's talk about smart infrastructure. Once it's mentioned, what comes to mind is sensors and digital technology. But Engineer Gabriel, from where you stand, how should we define smart infrastructure? And number two, are we investing in the right priorities in as far as smart infrastructure is concerned?
Okay, the smart infrastructure, as Engineer Diego just mentioned, he's mentioned a lot of things which are being used in the smart infrastructure. We have the Internet of Things, we have the data which is supposed to be collected so that the smart infrastructure can be monitored locally or whichever place you want to monitor it from. So the smart infrastructure is an infrastructure which you can easily monitor. You have sensors, you have data analytics, you have a monitoring station where you can go and see that this is where I am. You can see and monitor everything. And that monitoring is not just sitting somewhere and looking at it. It's something which can warn you that now you have a traffic signal maybe in a road somewhere. If there is anything happening there, it's supposed to warn you. If there's an accident, this camera which is put there is supposed to capture this one and take the control center. That control center will look at it and then it will be acted on with speed. So the infrastructure we are doing right now are right now they are still intertwined.
Yes.
We have the old infrastructure and the new one, but the government is trying slowly to phase out the old system and bring in the new system within the available resources.
I'm asking that because all over the world, we have seen countries that have successfully integrated green growth, digital infrastructure, and also matters of climate maintenance. Countries like Netherlands, Singapore, and even closer home, Rwanda. What lessons can Kenya learn from those countries?
Kenya is also trying. We are not very much behind.
Yes.
We are trying. The countries you mentioned, the Netherlands, those ones could be slightly higher. Rwanda is really trying. Sometimes we go to Rwanda to also benchmark, but whatever we are doing also within our own country is actually approaching the smartness within the constraint of time. Now, the government has also done a lot in this infrastructure business.
Yes.
We can now see that we have roads all over being done. These roads are supposed to be monitored, and there's a monitoring and evaluation team which has been set up within the ministries to go and keep on monitoring and collect data. These data, when they are used properly, they can easily inform of what is going to happen in those particular areas. We have dams which are being done. Right now, you can easily see that there's something which is going to happen before it happens. And if the resources are available, this thing can be attended to early enough.
Yeah.
So we are not very much behind.
Yes,
we are actually approaching.
We are on the right trajectory.
We are on the right trajectory.
Engineer Yago, when it comes to matters of sustainability, young professionals are considered as champions within that aspect. But when it comes to engineering, you have to deal with projects, engineers, you have to deal with budgets, timelines, as well as the expectation from clients. How do we strike a balance now between environmental responsibility, because we're talking about matters of sustainability, and commercial realities?
Thank you for your question. Yes, indeed, that's a very, very interesting question. Engineering, the way it has evolved, it has always been binary. That if I do X, the outcome will either be Y or Z. It's either a 0 or a 1. But then you find that when you are now, say for instance, I want to construct a building. Then when you do your BOQ, you do a bill of quantities. Then you now you start to be hit with the realities. There are taxes. So I had proposed material X, but now the VAT has increased. with the finance bill. And so it calls for engineers to also be very agile, that we are not meant to be rigid. What also helps us when it comes to that balance is that there's a lot of innovativeness that is currently ongoing. We have things like alternative building material, which have lower embodied carbon.
Yeah.
But now, usually, the challenge is not in the engineering front. At times, the challenge is on the client front.
Yes.
For instance, we have traditionally we've been building with rammed earth, but then it came a point where everyone started constructing with stones. But now the rammed earth has the technology around it has really improved.
Yeah.
But Mike, if I came and told you we can build with rammed earth and save the environment, and you have saved you've taken probably a mortgage from KMRC, and you want to say, and you know there's that perception.
Yeah.
Will I build with stone or will I build with rammed earth? But as people will say, we are mejenga nyumba ya matope. And you see there's that. And then there's also like we are not early adopters at times, because we find we have the technology like precast, which can save you a lot of time and a lot of resources. So you find many people are a bit cautious. They want to say, let me see at least 1,000 other buildings before I come. So the engineers are at the forefront, but at times maybe as engineers we probably are not very good at communicating. We don't know how to do the marketing pitch. So probably at times it's the clients who are a bit hesitant.
Yeah.
But hopefully with time, as they get to see innovative projects being done.
Yeah.
Like for instance, I remember a few years ago, Lafarge, or is it Holcim, they had pioneered 3D printed homes down in Athi River. But you can see there's that innovativeness, and that would save a lot in terms of the environment, because when you're doing a 3D printed house, you're basically precise. There's no waste that's going to be left. But you see, at times how is the client uptake regarding it?
Yeah.
But I can guarantee you that the Kenyan engineer is very innovative. We are at the forefront of many innovative technologies.
Yes.
Maybe we are just a bit behind in terms of communicating the benefits. Yeah. We're not salesmen.
That is a very interesting point, because when you look at resilient and green infrastructure, Engineer Jabongo, it often requires higher upfront investment. So how do you convince policymakers and investors to spend more today and save the country money in a lifetime of a project?
Now, the lifetime of a project you mentioned is normally a bit dicey, because during the lifetime of a project there will be a lot of policy changes. So what we do is that as an engineers, when we are making decision, we make the best decision for the country. We design for something which is resilient, something which is going to withstand time.
Yes.
But the problem is now normally the finances. So we normally do our design very well, or we do our proposal, or we write whatever assignment we have been given. Then we give the policymakers now. It is them now to see that does it make sense. But now, that is where now the changes now come in. There is some projects which are normally conceptualized without the involvement of the engineers. You find that the policymakers, they come, sit down, and then they give an engineering department or an organization something which has already been decided somewhere else without the engineers. So by the time now you are coming up with your costings, you find that the costing which you are coming up with is slightly different from the costing which was discussed on the table. Because at the time when they are doing this thing on the table, maybe an engineer was not there. Therefore, the data which was used was not the current data. Maybe they picked a data which had been used earlier in another project, and they think that this data will be used in this project. So we are saying that any decision which is being made, the the engineers should be there from the inception stage, from the onset. So we can give informed ideas, informed quantities, informed cost estimates, so that by the time it is being conceptualized, the government already knows that, do I have this amount of money to do this? So it doesn't come as a surprise. Yeah.
And when you look at Kenya's urban population, it continues to grow rapidly. And looking ahead, what would you say? Because we have cities like Nairobi, Eldoret, Kisumu, Mombasa. What should they prioritize if they want to become truly resilient and livable and cities of the future?
Yeah, okay. They should work on the industries. The industry, so that the population which is within that region can get some work to do. Yes. They should also leverage on their housing, which is the government is now doing very well with the rolling out of this affordable housing project. It is almost all over the place. So the population which is coming up will at least get a place to live in. They should get a place to work in. They should get a place where there are still kids can go to school. So we need schools also within those areas. And they also need a good health care. So the hospitals should also be expanded so that the population which is growing up, they can come up and grow, and the infrastructure which is within that area can also grow commensurately with the population.
Engineer Yego, and when you look at the country, many projects are ongoing. How can engineering help the country when it comes to development? How can engineering help the country deliver these projects sustainably rather than quickly?
Oh, that's a very loaded question. But I think just bouncing off what Mr. President has said. When you think about sustainability, sustainability is not conceived as the project is ongoing. Sustainability should be conceived before the project is even...
It should be part of the planning.
It should be part of the planning. And you know, when it comes to sustainability, there are many fronts to it. There's one, how are you going to build sustainably or enact the project sustainably? That's one element. The other element could be the project has been completed. Will it operate sustainably? And usually at times you think of at the very, very end, say it comes to a point where we'll have to, say, decommission something. Let's say there was like for instance, using an example of railways. There used to be a structure there, but now it had to be brought down so that another structure comes up. Now think about when it comes to the very end, say 50, 100 years from now, will it be able to also be decommissioned sustainably? So sustainability should be there from the onset, right from planning to the execution to the operation, and then now for future decommissioning. Yes.
Engineer Gabriel, do you think we are building infrastructure that meets today's needs, or infrastructure that meets today's needs and at the same time anticipates the challenges of tomorrow?
I think that's what is happening. If you look at, I can just give you an example of some of the projects which are ongoing, like the power stations. If you take like something like a dam, if you take at the dam which we have, any of them, Takwel has been there for nearly 20 years. So it means that when it was being conceptualized, the people who did that were looking at the future. It is still there, and then nothing has happened to it. So you look at also the roads which are being done now. They are being done. They are supposed to be sustainable. They are supposed to last for long. But then we have also the weather, which sometimes can be very unkind to some of the infrastructure we are doing. So we find that you've done something very well. You've done all your research, but then later on you find that there's something which just happen out of the way and destroys the infrastructure which has been done. But we know that most of the infrastructure which are being done, they are not for now. They are supposed to outlive the designers, if possible. So that the other designers who are coming can look at the way of decommissioning which was done by the previous designers, so that the new engineers can also come in and put in their thought. But nowadays we find that things are changing because the technology is really changing.
Yeah.
So we find that some people are actually sitting in the office and using IoT or AI to do the design, and they think that the AI will actually also supervise the project. But although the AI, the way we have 9, and right now you can use AI for supervision, but in Kenya we have not reached into that high level of doing that. So we are still must use the engineers physically to go and supervise some of these projects.
Very important. And we look at many public projects. Sometimes they are awarded largely on probably the basis of the lowest bid. From where you stand, does that procurement model encourage innovation and resilience, or it sometimes becomes or undermines the quality and long-term value of a project?
I think that's where we go wrong. The lowest bidder is not normally the best. This thing is normally, if you get a good project, this from the beginning, there must be an engineer who has put in a thought in this. He gave a specification of the various elements which he wants to be used in this place. And then there's the tendering process, which is now taken over by the procurement entity. And then there's that selection of that contractor. Now, the contractor, if you look at the lowest cost, you have to look at the element within the costing itself. What is making it be low? Some of the items which may be, the contractor could have got it wrong. He's quoted very low, as opposed to what you can get on in the market. Then you end up giving him the project. He will not deliver. So we normally want, although you look for the lowest, but it must be we call it lowest evaluated bidder. But no, you start from the technical and then the financial.
Engineer Yego, when you look at county governments, are there mistakes they should avoid when it comes to planning? Because some of these mistakes may contribute to issues like flooding.
Please come again.
Looking at county governments, how can they avoid planning mistakes that maybe contribute to issues like flooding, congestion within cities, and costly maintenance?
Okay. I guess probably this is why we are even having the conversation at the upcoming conference. When it comes to things like nature events and whatnot, yes, as engineers we use data, historical data, current weather data, and so on and so forth. But it also has to be in synergy. We work together with, say, the planners, we work with the architects. And so what we need to, or rather what probably the counties need to move away from is a silo mentality that we'll probably work with only the planners and with our master plan. No, the thing that needs to happen is bring all the stakeholders on board. Bring the engineers, and not one engineer. Bring the broad scope of engineers, and it's helpful that you have an umbrella body like the Association of Consulting Engineers. You invite them; they will come with all the expertise. Bring on board the Architectural Association. Bring on board the planners, because it's not a one-stop. Not one person can be able to plan all this. It has to be a collaborative effort.
Very important, very important. And you've mentioned about the conference, and maybe you'll tell us when it's happening.
I can just chip in on the planning issue. You see, counties normally have master plan. This master plan, even in Nairobi, there's a master plan which was drawn long time ago. But as things go, you find that this master plan is put under the table. The planning, the development now takes over, and some of them have done haphazardly. They don't follow the master plan which has been there. In the master plan, there are normally water corridors, where if at all it rains, this water is supposed to find its own way, maybe to the river somewhere. And then you find somebody has built in that particular area. So people are blocking the drainage system, not because they like it, but because maybe somewhere within the line, the planning department either relaxed or they didn't do their work properly. So that's kind of a things happen.
The conference?
The conference, The Association of Consulting Engineers of Kenya is organizing a conference in Sawela Lodges in Naivasha, and this will take place from 12th to 14th of August, actually next week.
What is it about?
It is what we are discussing about. It's about the resilient, smart infrastructure, and green growth. Yeah, we are expecting to get almost 700 participants.
Yeah.
This will include the government bodies, the academia institution, the industry, the engineers themselves, and there is also the manufacturers who are going to showcase what they have been doing around, what they have been doing. The universities will also come with their prototype of what the research they have been doing, and it is a good opportunity for anybody who wants to see what is actually happening to come there and actually see for themselves. It is going to be a 2-day event. The third day will be for a site visit. We have very good sites to be seen within the Naivasha area, and we also have the first day, what we call Future Leaders Symposium, which maybe Engineer Yego can probably expound on. But this is the conference itself will be opened by the CS Peter Wandai, the CS for Energy and Petroleum.
Yes. Yeah. So that was our time, gentlemen. That was our time. That was our time. And I thank you for making time to come and just talk about how we can scale green growth, smart infrastructure, and resilient futures. That has been Engineer Gabriel Jabongo, who is the President, Association of Consulting Engineers of Kenya, and also Engineer Nathan Yego, who is a member of the Association of Consulting Engineers of Kenya, Future Leaders, and ASEC Conference Committee. Thank you for tuning in. This is where this conversation ends.